Hi, this is Prof. Rassi. In this lesson, we're going to learn about logarithmic functions. In the last lesson, we looked at exponential functions. So y equals 2 to the x, that's an exponential function. We see it starts slowly and it grows quickly, like the spread of the coronavirus, or hopefully invested money grows exponentially. In the unit before, we talked about inverse functions and how every function needs to have an inverse, which is really the reflection across the line y equals x. Here we see that inverse of an exponential looks like this. We also see the equation here in x equals 2y, but if we want to solve that, we have to solve it and rewrite it as y equals log base 2 of x. So logarithms are really the inverse of exponents, and we'll dive into that more later in this. For now, I just want you to see that any equation y equals a to the x has an inverse, which is y equals log base a of x. Before we dive into it, let's just look at some exponents first, because that's really what's going to come into play here. So if you think about exponents, 2 to the 0 power, type in your calculator if you need to, but anything to the 0 power is 1. 2 to the first power, 2 is just 2. 2 squared is 2 times 2, which is 4. 2 cubed, 3 of them, right? 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. Now, 2 to the negative 1. We've talked about these negative exponents. They're a little pesky, though. Remember, we move it to the denominator and make it positive. Or if it's in the denominator, then we flip it to the numerator. So 2 to the first is really 1 over 2 to the first. 2 to the negative second is going to be the same thing. 2 to the negative second, 1 over 2 squared, which is 1/4. I don't think we've talked about 2 to the 1/2 or 2 to the 1/3 yet. 2 to the 1/2 is just the square root of 2. 2 to the 1/3 is the cubed root of 2. And these are going to be helpful because we're going to be going back and forth between these. So if I say, hey, I'm giving you 8, and the base of 2, I'm going to say, what's the exponent? And you're going to have to think 3. So let's try another one. I've got 1/4. The base is 2. What's the exponent? And you're going to have to be able to say, oh, that's -2. Don't worry, not quite yet, but that's where we're headed. Let's look at 3. So when I look at 3, 3 to the 0 power is 1. 3 to the first is 3. 3 times 3 is 9. Multiply 3 together 3 times, I get 27. And 3 times itself 4 times is 81. Hopefully you're getting comfortable with these. 3 to the negative 1, hopefully you're thinking 1/3. 3 to the negative second is 1/9. 3 to the 1/2 is the square root of 3. 3 to the 1/3 is the cubed root of 3. Let's look at 4. You're going to see some similar patterns, right? 4 to the 0 is 1. 4 to the first is 4. 4 times 4 is 16, so on. 4 to the negative 1. Hopefully you're not afraid of these negative exponents. By the end of this lesson, we get 1/4. 1/16, 4 times 4. And now, 1/2 power is the square root of 4, which is just 2. Let's take a look at 9. I'm leaving some of the easier ones off. 9 to the negative first power. Hopefully you're thinking 1/9. 9 to the 0, anything to the 0 is 1. 9. And the 1/2 power, square root of 9, which is 3. Great. Erase something I don't want to erase. Alright, let's take a look at 10. It shows 10 because 10 has an interesting property that happens with it. So let's take a look at this. 10 to the 0, anything to 0 is 1. 10 to the first is 10. 10 times 10, 10 squared is 100. 10 cubed is 1,000. 10 to the fourth is 10,000. Do you notice a pattern here? Notice, if you think of this as 1 point, 10 to the first is 1, 0, where I've moved the decimal point over 1. 10 to squared, I've moved the decimal point over 2. 10 cubed, I've moved it over 3. 10 to the fourth, I've moved it over 4. What about negative integers? Exponents, I'm sorry. I know, your favorite. Well, again, 1 over 10 to the first power. If you type this in your calculator, you're going to get 1/10 or 0.1. Same thing happens with 10 to the negative second, is 1/100th, or 0.01, 0.001, or 0.0001. Notice what happens here. This should be tying into your memories of scientific notation. Remember here I was moving the decimal to the right 1, to the right 2, to the right 3, to the right 4. Now notice I'm moving the decimal to the left 1, moving the decimal to the left 2, left 3, and left 4. So when you're working with exponents on 10, recognize there are some shortcuts you can use if you're comfortable with them. That concludes this video. Quick summary. Logarithm, we'll get into them a little bit more in the future videos. It's really the inverse of the exponential graph.